Today, your hosts for the workshop are Dave Carter and Josh Entz, and I'll be passing it over to them in a few minutes after we go over some housekeeping items. But first, I wanted to welcome everybody and thank you for joining us today for our Kinematics in 2 Dimensions workshop. Just to let you know that I will be putting the link to the handouts that will be used today in the chat feature on your menu bar. So you can just click that link and it will take you directly to the handouts that Josh and Dave will be using. We do ask that you use the Q&A function for asking questions. We will be monitoring those throughout the workshop and answering those as we go along. You can do some comments in chat if you'd like, but we ask that you use the Q&A for questions. If we happen to not get to your question today, we will be following up with you after, so don't worry, your questions will be answered. And just to let you know that the recording will be available on our website after today in our video training library, so you'll have access to the recording anytime you'd like. And we'll also be providing a certificate of attendance to attendees who join us live today, so you can look for that. So look for the link in chat in just a moment, and I'm going to pass it on to Dave and Josh.
Why don't we go ahead and get rolling with the workshop here. I'm David Carter. I'm the STEM training director for Vernier. I've been using Vernier devices and whatnot for over 30 years now. And I got my start when I ran the instructional physics labs at the University of Mississippi. So we were using early versions of Vernier products there. So I taught college physics, I taught middle school, I've done a lot of PD for math and science teachers over the years, and I've worked in one way or the other for Vernier since 2002. So, so that's my background. We also have with us today Josh Entz. Josh, you want to say something about you yourself?
Sure. Hi, everyone. I have worked at Vernier now for about 6 years. Prior to that, I was a high school physics and engineering teacher. I taught in Northern Virginia and taught everything from conceptual physics up to AP physics. I was also the a mentor for our school's robotics team, and I got a lot of opportunity to do engineering type stuff through that experience. Here at Vernier, I do things like teacher training. I also help out with product development. Right now, I do a lot of customer service stuff. So if you email us or call or chat through our website, you might get me or one of our other colleagues here. Most people that you interact with at Vernier have some sort of teaching background, and we kind of understand where you're coming from.
Okay, thanks there, Josh. Today's topic was kinematics in 2 dimensions, so projectile motion. And what we want to do is we're going to do a couple of different things. We're going to do walk you through a lab from our physics with Vernier book, and we'll talk about what that's about, where the lab came from. I know you got a link to that, and we'll talk about that. So I'm going to do that, and then Josh is actually going to be using our Vernier video analysis, and we'll show you how that works. And then if time allows, we may be able to actually show our projectile launcher as another option. And we may even be able to squeeze in a little bit of the Graphical Analysis Pro, which actually launched yesterday. So we'll talk about that. So the first thing I'm going to do is talk about some of the resources that we have right now. So if you're trying to teach remotely, this might be a way to be able to do this. So what I want to do is just share my screen. I'm going to go quickly to the Vernier website, show you a couple things that are there that relate to today's topic, and then we'll go on from there. So so let me do this. I'm going to go share my screen, and so what you see there is just the Vernier homepage, and you'll notice that right at the very top, it says explore remote solutions. So these are things that for you to be able to do maybe in a virtual world. And so when I go here, I can scroll down, and I'm going to do high school here. There's a crossover with some of these, but I'll just go and click on the high school. And as I scroll down, you'll see that there's some options. We did a webinar about this back in the spring. But we're going to be doing a couple things today. The Vernier video analysis, that was what Josh will be doing for kind of the second part of this, where he'll be showing that tool, which is really useful. But I will be starting off by using some data from our data library. And so what we did is we put up completed data files that go along with some of the labs from our various books. And the idea was that if you were in a virtual situation where you cannot do the lab yourself, we have data available for that. And so your students could use that data for the analysis. But what we want to do is kind of show you how that was collected. And then maybe talk about how maybe you could do it yourself and share that data with that. So that's what we're going to be doing. So I'm going to start by just going to the library there. And so if I go to the library, you'll see that if I want to browse the library, I can see all the ones that are available. So I'm going to go here. And it's actually defaulting to showing the links for biology right now. So at the very tippy top up here, you've got links for biology, chemistry, physics, and then things that are middle school, elementary, physical science kinds of things. I'm going to go to the physics section. And what you'll see is that we have the different books that we have. And we've chosen some labs out of there. It's not all of them, but we've kind of chosen some that we thought might be pretty easy to do kind of in a remote situation. And so it lists the lab and it lists the software that's used with it. And then if there is a video that maybe goes along with it that talks about that lab, there would be a link there. So you'll see the different books. Now I'm going to be coming down here and we're going to be doing projectile motion, which is experiment number 8 from the Physics with Vernier. So that's the book I held up there. And we're doing the version that uses the graphical analysis app. And graphical analysis is a free app that can run on 5 different platforms. You can run it on Mac and PC and iOS. So I've got it here on my iPad, my iPhone, Android devices, Chromebooks. That's always the question people want to know. Does it run on Chromebooks? And the answer is yes. And so students can get that app for free, and then they can use the data file and be able to analyze that. So that's where this stuff is coming from. And so if I actually went here and clicked on it, it's going to take me to a place where I could download the data file, which is this .ambl file. And so that is a graphical analysis file. And then there's also the Word doc, or a document that has the lab itself in there. So what we've done is essentially put up some of these labs on here for free and be able to, and so that's where that came from. So. And so what I want to do now is let me stop sharing that screen. And I see we've got maybe a question there already. So what's that question there, Josh?
How long will those data and experiment documentation be freely available?
That I do not know. I would imagine we're going to leave it up for quite a while. It's so probably through next year would be my guess. I don't know if when things kind of get back to normal, whether or not that'll go away, but so it'll be there for a long time. If it's something that people can use right now in their teaching, it'll still be up there. So, okay. So at this point, I actually want to do the lab, and I've already downloaded it and everything. And what this lab is about is using a photo gate like this one. And this is the GoDirect photo gate. And it works with the graphical analysis app and allows me to measure, in this case, the velocity of a ball rolling off the edge of a table. And the way it works, as I can hold up here to the camera, is that you've got some LEDs on one side and you have a detector on the other. And this one has two of them. So there's a set of them. And so it can measure that velocity of that ball as it rolls through. Now, some of you may have done this in the past with our, say, the older version of the PhotoGate. And what is in the older version, you would need to set up 2 of them kind of daisy chained together. so that you essentially, you only had one detector, and you would have to have both of those going so that you could measure that. You can still do this lab that way. And in fact, in the book, the lab, there are different versions of, depending upon which device you're going to be using. And so we're going to be using this device today. And so I'm going to be using it wirelessly. These new GoDirect sensors can be wired, so you can plug it in via USB and it would automatically work with the software. I'm going to be using it wirelessly because I've got my setup here behind me, and I'm going to set it up so I can roll it off a table onto another table in this case. And I'll be showing a different view of the camera there overhead so that you can see that. So at this point, what I want to do is I want to, I want to share the graphical analysis app with you. And so what you see there is I've launched the graphical analysis app, and I've turned the sensor on. So there's a little on-off button there, and I turned it on, and it's flashing, which lets me know that it's available. And I'm going to go up here to sensor data collection, and we're going to see what sensors are available for me to connect to. Now, I'm showing the top one is the photo gate. The other one that's showing up is the CO2 sensor. I happen to have it charging across the room, so it's on. And so we can see that. I don't want to connect to that one, but I want to go to the photo gate here. So I'm going to connect to the photo gate. And so it's connected, and by default, it connects to what's called object velocity. And so it's designed to be able to track the velocity of an object coming through that. So really for this one, I don't have to do anything. It's all set up and ready to go. Now, another common use of this mode would be to use my picket fence, and I don't know what I did with my picket fence. I've put it under something here. Well, anyway, so I had a picket fence that you can drop through there, and so you can do that. At this point, so we've got the, I'm connected, so let me say done. And I want to do something here. Again, this lab, we're not actually going to be showing any graphs or anything. For this one, the way the lab says to do it is that you're actually going to be doing it in a meter mode. So you just want to be able to get the velocity of the ball coming through there. And so to do this, if I go up and say I want to do meter, I'm going to turn the graph off. If I do meter, let me do this. I'm going to put it in presentation mode. So it's a little bit bigger there so we can see that. And so now we've got a meter display. And if I go through, notice that I'm getting positive and negative values depending upon the direction that I go there. So it actually already does that for me. So if I'm breaking it, it's measuring the velocity. As I break the first beam, I break the second beam, it just knows how, it measures the time, knows how far apart they are. They're 2 centimeters. You can measure that. So at this point, what I want to do is I want to, let's see, I need to stop sharing this one. And I need to go up, and I want to switch cameras here. And so what you're seeing now is my, the camera that I have set up behind me here. And so for this experiment, it's a little bit hard to tell here, but I have a table set up, and this is basically is a table that's 35 centimeters below this one. And the way this would work is that I'm going to set this up, and I'm setting it up this way. I want to make it so that when the ball rolls through, it's positive, and it tells me that which direction that would need to be there, and so I've got it set so that way I get a positive velocity. And then the other piece of this is that I'm using, for my ramp, I'm using a ruler that I actually kind of filed down the end of it so it would sit flat on the table. The lab suggests that you might use something like a track or an angle or something that, you know, the ball can roll down, and I've just got it sitting up on a stack of books. You can't quite see that there in the video, but just so that it is angled, so when I roll the ball down, it will go down there. And what I'm trying to avoid here is having it bounce. And what the lab ask the students to do? Well, the first thing is to think about the independence of motion here. And the very first part actually has them start off by taking a couple of pennies, and I've been practicing this and it probably won't work here. I've got it set so that if I hit one, I'm going to try to launch one off in that direction and have the other one just drop. And so the idea is to think about what's going to happen. Are they independent? Will they hit at the same time? We probably all know that students are going to be like, oh yeah, the one that you've sent sailing, it's going to be in the air for a long time compared to the other one. And so, so they could go through and do that. They sounded like they hit the same to me. I didn't really give one a really good launch, but that's the very first part of that. And so if you looked at that lab, it has some questions for them to be building up to think about what's going to be happening with the motion. So those first preliminary questions, if you're looking at that, they got to do the prediction and they do all that. So for the data section of this, what we need to do is, let me go back to my, let me go back to sharing the app here. Let's see, I want to stop doing that. And let me go back to the app. And so now we've got the velocity. And what the lab says to do is to roll the ball through there several times and just get the value of this. And of course, it's very important that the students put the ball at the same spot when they start and when they let it go, because the idea is that they want to know what the velocity is and then from there predict where the ball is going to land. So if I come up here and I'm just going to put the ball at the top of the ramp and I'm going to catch it, because they don't actually want you to let it land, because that way they kind of know where it's going to be. So I'm just going to roll it, and that velocity is, so I'm going to do another one. So they would have written that down in the data table there, maybe do another one. You'll notice that they are very similar. So I'm really not getting much difference here. So, 0.88, something like that is the actual value. So at this point, so I tell you what, I'm going to go back and stop sharing this one and go back to that overhead view. So Josh, are there any questions so far about that?
Not yet.
Okay. So what I want to do, I actually wanted to show the camera and with it rolling through there, just so you can see what's going on. So we'll see if we can see that. It's a little hard to see probably. And so the other thing that I've done is I've measured how far the table is below there. Turns out to be 35 centimeters. And the task that the students are asked to do is to take the data table and from that predict where the ball is going to land. And we could, Josh and I debated about this, we could say, well, we've given you enough information right now that you should be able to figure out how far the ball is going to be, how far it's going to go. Now, I didn't mention that I've put the tape here is I dropped a plumb bob from here down so that it was right at the start of the tape. So that should be in line in the vertical with that. And the idea is for them to figure out where in the world it's going to land. Has anybody run the math on that yet? I'm going to give you about 30 seconds. So remember what the velocity was. It's 0.888, let's say, meters per second. It's 35 centimeters down. Now Josh is running it. He's running on it. and then we'll, I don't know. I don't see anything in the Q&A. I don't think anybody's putting any answers in there. So I don't know. You know, the students always ask if this is going to be on the test. And did you get a value there?
Yeah, you said it was 35 centimeters, right? From the
35 centimeters from there to there to in the vertical.
So I've got a hang time of 0.267 seconds.
Okay. Yep.
Traveling horizontally at 0.88 meters per second.
Yep.
That would mean you should reach that lower table there, 23.5 centimeters from.
Okay, so 23.5. That's the good news is this is really consistent because I ran this a bunch yesterday just to make sure it was working, and that's exactly what I got. So at least the math's not lying to us. So what I want to do is I'm actually going to put a target there. And so let's see if we can see the target, which camera I'm using. So I just use the lab suggests in the back that you might use a cup, either a paper cup. And so I had a little styrofoam cup that was sitting in my collection of science goodies. And so what I'm going to do is put it down centered at 23 right there. And then I we'll roll this down and maybe, oh, but I got to make sure I'm in line though. I'm slightly offline. We'll see if I can hit that. All right, see if Josh can hit it because it was his call. Yay! Woo! It worked. So we at least know that I happen to be in Tennessee, and Josh is in the Oregon home office. So I would suggest maybe that the gravity is very similar between the two places there. So what we've done in terms of the experiment for this one, let me go back and I want to share the graphical analysis. Is that the file that we put up is basically just data from a trial of this. And so you could come up here, and if I did new experiment, I can choose the file, and I put it on my desktop, and it's that one. And so the issue is that if you're opening up a graphical analysis file, you need to make sure you open it up inside of the graphical analysis app. You don't do the others. So there's the actual data. And so the idea here is that we give them the height, and they're going to try to predict how far it would have gone when we did that. And so it's a fairly standard projectile motion lab that's pretty easy to do there. So, okay, let me do this. Let me go back and stop sharing that. And I want to, let's see. Oops. Start my video, and I need to switch cameras again. It's always fun switching back and forth. There were a few questions that came in through chat. And I guess Josh actually answered some of those, I think. So, okay. So that's just one example of some of the data that's there. And keep in mind that this could be a way that maybe you do it, where you set it up. You set up the scenario, and you say, well, I'm going to drop it from this height. You guys have to, your students have to go in and calculate where it's going to be and run the test on it. So that was using it with sensors. And I think the next portion is the video analysis. And so Josh, do you want to take it away from there?
Before we do, Dave, do you want to explain a little bit about the idea how we envisioned people using the sample data, that sample data library?
Yeah. you know, there are a lot of situations now where we know that you're not going to be able to have the students collect the data themselves. And so, but you may want them to be able to analyze real data. I know that, you know, for people who are teaching AP, that's been an issue. It's like, well, they're required to do some labs for AP, and I know AP is making some, you know, compensation for where we are right now, and that the fact that you have the data set that the students can analyze, and that just allows them to be able to almost do a lab and to be able to do that. So that's the why, and so.
All right. While we make this transition here, let me just admit that I have never taught remotely. I was in the classroom for 10 years, and I enjoyed being with the students and doing especially hands-on science activities. I felt like that was a valuable experience for my students. And so I very much appreciate the work that you're putting into making an interesting and engaging class for your students as best you can in this crazy situation that we're all in. As I was helping my kids get on their Zoom class meetings this morning before coming into the office, it's a much different job than you have right now. One of the tools that we at Vernier offer that really shines in a moment like this is our Vernier video analysis app. We've been doing video analysis for many years. For a long time, it was through our Logger Pro software. That's still available. We have an app for iPads called Video Physics that also does video analysis. Recently, we created this Vernier video analysis app because teachers wanted to be able to do video analysis on more than just the iPad or a computer. They had Chromebooks in their classroom, and Vernier video analysis allows that. So what I'm going to do is I'm going to explain a little bit about how the app works. I'll work through a typical, analysis process. I've got a video. How do I analyze it? What kind of data can I gather from the video? And then I'll I'll show you some things that kind of make that analysis, that process a little bit easier. I'll spend a little bit of time explaining how some best practices for recording student videos, like when students make their own videos. And I'd like to show you some other ways of using the video analysis app for topics other than just projectile motion. So first, I'm going to share my screen here so that you can see the Vernier video analysis app. This is the app itself. Some things you'll notice right off the bat here is that it runs within a browser. I have Google Chrome open here, and the address right now is Vernier or videoanalysis.app. And when I launch that app, it opens in my browser, and I have the first step is to really just choose a video. What do you want to analyze? You can create your own videos and import them. We have here a number of sample videos for you to choose from. I'm going to just do this very first one, this basketball shot video, because it's what most people are when they think of video analysis, they think of projectile motion and analyzing the motion of like a projectile. Video analysis, the app is intended to be used the same way you would use like a probe, a temperature probe, or a motion detector in your classroom. The idea being that you are going to gather some data and then analyze it using the available tools. If you collected motion data, you might perform a curve fit and look to find what the slope of that linear line is to find out the speed of the object. We can do that same sort of thing through this video analysis app by collecting data from the video itself. It starts with a video. Here we've got one of our local physics teachers, Joel. He's going to shoot a basketball. I'm going to just hit play here so you can see what the video is. It's kind of a boring video. It's boring because we want to get some clean data out of it. I'm going to advance the video to the point where the ball is in the air. And at that point, that's where we would say the ball enters projectile motion. And that's at that point we have we want to start collecting data. In video analysis, what you do to collect data is you place data points on top of the video. So right now, I've got these crosshairs here. Wherever I click, it drops a data point. For a basketball like this, I could click the very center. Sometimes it's easier just to pick some point on the ball, like I'm going to click the top of the ball here. And when I do, it's going to leave behind a little video, a little data point. And the app automatically advances the video another frame, and I can drop another data point, and I can just go along here and drop data points where the basketball is or where it has been. And as I repeat this process, you can kind of see you get this visual representation of where the ball was. And you'll also notice that on the right-hand side of the window here, I'm also getting a graph. I've got a data table is being filled in, and then using the data in that data table, it's creating a graph of the motion of the ball. If you look carefully, you'll see that it's graphing both the X and Y, the horizontal and vertical position of the ball. I'm going to continue here until I'm looking for that, characteristic parabola that we always talk about when we talk about projectile motion. All right. All right, so I've collected some data. And if you want to look at the actual data, I'm going to grab these little handles here so I can shrink my video a little bit so I can see my data table a little bit more. And it's got values in it, but it's a little bit confusing. Time I can see, that kind of makes sense. That's time in seconds. The app is getting this time from the video itself. It knows that this video has been filmed at 30 frames per second. So it can apply a timestamp to each one of those frames. The horizontal and vertical position of those data marks come from, you'll see the units are px for pixel. It doesn't really know anything about the video. All it knows is you've clicked here, and it knows the pixel location of where you're clicking, assuming that the lower left-hand corner is 0, 0. If I want real data out of this, I want to know, how fast was it actually traveling. I'm going to need to set a scale and an orientation. And those are options within the app here. So you'll see kind of on the left-hand toolbar, I've been on this feature where you can add data points. There's an option to edit the data points. So if you've messed one up, you can select it and nudge it one way or the other. Or if you clicked wrong altogether, you can just delete it. But I want to go to this system option. And here I can set a scale and set an origin. In this case, because we knew we were going to analyze this video, Joel very helpfully included a meter stick down here on the ground in front of him. And I'm going to take and move this little stretchy line here so that it begins and ends at that meter stick. Or that stretchy line, as you adjust the stretchy line here, you're adjusting this scale here. The app is now going to say every 237 pixels is equal to 1 meter. So now by adjusting that scale, you can see that my data table changed. Instead of measuring a horizontal and vertical position in pixels, it's measuring it in meters. I can also choose an origin. So I'm going to click here, and then here I can take and I can drag my origin here so that it lines up. Maybe I want to line up the origin with Joel's feet. So there's the Y and the X axis. One thing to note is as you drag this around, you can see that the measurement, the graph over here changes as well. That's because I'm just changing where 0, 0 is, and so the measurements from 0, 0 change as well. Now that I've got a scale and an origin, I can look over here on my graph. I'm going to slide this guy over a little bit, and so I can see my graph a little bit better here. And I can see that these blue dots, that's the vertical position of the ball. The red dots, that's the horizontal position of the ball. And I can do all sorts of analysis here. Maybe I want to know how high the ball went. And I can look to see, let's see, here's the vertical position of the ball. Where is it greatest? I'll click here, and I can see that the highest point in its trajectory was 4.33 meters above ground, or at least above wherever I've called ground here on my in my origin. Maybe I want to know the speed of the ball as it's moving sideways. So I'm going to do a curve fit here. I'm going to go to apply curve fit. Then I want to do a linear curve fit and apply that. And it looks like, so the red line here, that's my horizontal motion. And it looks like the slope of that line is 2.316. So that's about 2.3 meters per second that the ball is moving forward horizontally. Maybe I want to know what the acceleration of the ball was. I know that the acceleration, because this vertical position is parabolic, that there's some sort of acceleration there. And so I could do a different curve fit here, and I can choose a quadratic fit and apply that. And then I get an equation of motion for the vertical motion of the ball. And I can see here, if I scroll down here, the blue data is the vertical motion, the vertical position, and the acceleration there. Well, let's see. This isn't exactly the acceleration. That coefficient A there is equal to 1/2 the acceleration. So this is negative 4.8, 4.9. If I double that, I get somewhere around 9.6. I know that it should be about 9.8. This is kind of a quick and dirty sort of analysis. Your analysis obviously is only going to be as good as your data, and your data is, in terms of video analysis, is only as good as how well you click. Let me show you a few things about how to make your analysis a little bit better, or make it a little easier to do an analysis like this. I mentioned before that you can edit the positions. If you find that I kind of messed up here, this data point needs to be a little bit in a different spot, you can click on that data point and you can nudge it one way or another. Another thing you might find is that the video, your students make videos, and the projectile's in the air for all of 2 seconds, but the video that they recorded is 20 seconds long. You can adjust where your video begins and stops by using these little trim arrows down on the bottom here. That way, if you go back to the beginning, it defines what that beginning is. Another place that if your students record high-speed video, it may be that the object moves so little in between each point, it's hard to see if there was any motion at all. Within the settings of the video, you can change how much the video advances each time you drop a data point. So if you're filming at 240 frames per second, maybe you'll want to skip 10 frames between each data point. Likewise, you can adjust the frame rate to match that of the video. Sometimes, especially with smartphones these days, they record high-speed video, but then they're set to play back at the standard 30 frames per second. So you see that slow-mo action. But when you're doing the analysis, that'll mess up all sorts of that slow-mo action, messes up the data stamps or the timestamps. And so by adjusting that frame rate, you can have those timestamps be what you would expect them to be. Likewise, if you're having a hard time telling where to drop the data point because of the other data points that are already in there, you can turn those trails on and off so that if you need to, it's a little easier to see what you're doing. And the last thing, I'm gonna go back here, and I'm just going to you can have it automatically track the object if you set up your video correctly. So I'm going to go back to my to adding data points here, and I'm going to choose. Well, maybe I'm going to start over and do this one again. I'm going to go to new experiment. I don't have to worry about saving this. I'm just going to kind of clean the slate here by restarting with my projectile motion video. And like before, I'm going to advance to the point where it's just left his hand. We set up this video so it's got a nice boring background behind it so that you can see the object tracking. I can adjust these crosshairs on the object that I want to track, my basketball, and I'm going to adjust how much it pays attention to. I'm going to say right about there. And I can start auto tracking. And at this point, the software is picking out that ball or my object from the background and in each frame and dropping a data point accordingly. You'll notice that it works really well when it's on this plain background here, but then it loses it when there are big changes or when the background gets kind of busy. You know, down here there's this gravel on the sidewalk and stuff like that. It kind of loses it. But you can see that that worked really well. It's really smooth. You'll find that some videos, if you set it up correctly, you can get auto tracking to work beautifully. A lot of times if students are making videos outside, there's going to be lots of kind of trees or bushes in the background, and, or you know, a brick wall or something like that, then the auto tracking might not work well. You can always go back and adjust. You can always go back and just manually add the data points. But in some situations, auto tracking is really great, and it kind of simplifies the data collection process. You know, it gets me to this point here where I can begin my analysis and do my curve fits and find the values and that sort of thing. Kind of the last part of the process here, you've got your students, they've done a lab here within video analysis, and they want to share their results with you. You know, maybe they're writing up a lab report, but they actually want to save the data file with you. You can do that within the app. You can say, you go to the file menu, and when you hit save as, it's just going to download a file with just, you know, whatever name your browser happens to give it. Unfortunately, it really just depends on how the browser downloads, you know, untitled files, but it will send that file to your downloads folder or wherever it's specified, and it saves it as a VMBL file. That's a file format that you won't be able to just open in Excel, but it can be opened within this Vernier video analysis app, and it includes the data, any analysis, as well as the video itself. You know, so if you want to see the videos, you want to see the analysis they've done, you can have them then download it and save that VMBL file and then share it with you, either through email or through a shared Google folder or something like that. All right. Are there any questions at this point before I move on? All right. In the downloads from today, for this workshop, there was the projectile motion sample data and the lab write-up that Dave walked through for that projectile motion lab. There's also a PDF titled Projectile Motion, which is a lab for this app for Vernier Video Analysis, where students record their own projectile motion, and then the lab describes how they analyze, you know, collect the data from their video, and then analyze the data for the projectile motion. There's also another document in that shared Google folder that Angie put in the chat there that has tips on collecting data and collecting videos and that sort of thing. Let me show you that. It's called VVA, Video Capture Instructions and Analysis and Advice. And it kind of gives you some tips on how to record good videos. You know, for instance, use a tripod. You know, you want as good a lighting as possible. You know, ideally outside, because sun is a great light source. If you're recording inside, nice bright lights are good to have. Probably the most important thing, especially when you have students creating their own videos, is that you want the plane of motion. So you imagine the projectile moving through the air, you know, it's kind of moving through a two-dimensional plane there. You want that plane of motion to be perpendicular to the camera itself. You know, you don't want the projectile getting closer to or farther away from the camera as it moves. Likewise, you'll want to include like a meter stick or some sort of object that you can take the scale from. You know, we often use meter sticks because, you know, we're in the physics lab and we've got one available. But if there's some other object within the video that's about the same distance away from the camera as the projectile that you can take the scale from, then the students can measure that out, or they can put a tape measure out there, or mark it out, you know, in chalk or something like that, so that when they analyze their video, they can scale it very easily. This
Josh,
I'd encourage.
I've got a question that I want to raise with you. Somebody raised. You might
Sure.
want to address it now. They're asking about uncertainty. Basically, how do you end up dealing with uncertainty in the measurements with the video analysis?
Yeah, so just like any experiment, there's going to be some uncertainty. The uncertainty in the video analysis comes from where you drop those data points. So obviously, students want to be very mindful about where they place them. One thing that you can do, I don't know that I showed, is that on your video, you can actually, I'm gonna move. One thing you might do is move these things off the way. You can even, if you want, you can turn off these things altogether. You can turn off the graph and the data table just so, and you can actually zoom in on your video and drop data points. Sometimes that's a little bit easier to do it that way, zoomed in as well. But again, there's still that uncertainty. You know, you're plugging those data points on there, and if, especially if the object reaches kind of the edges of the video, or the video frame, then there might be some distortion there in the video. And so where you're dropping the data point is going to be a little bit fuzzy, you know, how well that lines up. If the camera itself isn't, if it's on a normal camera, like if it has a fisheye lens on it and stuff like that, obviously that's going to limit how much of the video frame you can use. But that's a discussion that you've got to have with your students, like how well our data matches what our expectations, or the scientific principles that we're describing really depends on how well we've collected our data.
Okay, Josh, we're approaching the end here. A couple other questions before we maybe move on. One question about, is this a locally installed app or is it web-based?
Yeah, so it's kind of a new sort of thing. This is what's called a progressive web app. That means it's an application that runs within a browser window. In this case, I've got Google Chrome installed on my computer here, so it's running within Google Chrome. Once you've run it once, it's installed in the sense that you don't need to be connected to the internet. It'll still open within the browser window, but you don't actually have to be connected to the internet in order to use the app, you know? When you have the app, you as the instructor are going to want to share this app with your students, and you can do that within the app. You know, you go to when you purchase it from us, or if you sign up for the free trial, you'll get an email from us with a link. You click on that link and it will launch the app within your browser window. The first thing it'll ask you to do is to accept the end user license agreement. And then it'll go straight back to this same, you know, new experiment menu that I showed before. This one here. From within the app, if you want to share it with your students, there is a distribute button. In the upper right-hand corner, there's this 3-dot menu, this overflow menu. And one of the options is to distribute the app. And that gives you this key, this kind of big long link here. You can copy it to your clipboard and then paste that onto a course website, or put it in an email to your students. Then when they click on that link, it'll open up their browser and take them to the app. At that point, they'll want to bookmark it or I think that's the easiest way to hold on to a link, just like if it were a web page. But that's the easiest way to share, is just by using this distribute app, getting another copy of the link then that you can share with your students. Some other cool things about the app, you know, they have, you can add vector displays on top of your graphs. One of the things that I really like to do with video analysis is do things like, is this video real or fake? You know, for instance, back when I was teaching, I downloaded a video from YouTube of Kobe Bryant jumping over a pool full of snakes. And this video, you wouldn't think, it's from YouTube, obviously. You wouldn't think it'd be worth anything in terms of data collection, but they switched to this great scene. And the whole time that he's in the air, it's perfect. You know, you can analyze this video. And so we would typically start off with a video like Joel's basketball shot, very boring, simple, when we were talking about projectile motion. And then as we were wrapping up the unit, as a practicum, I would hand them this video and say, I want you to use your newfound video analysis tools, and I want you to analyze it and tell me whether this video is real or fake. And they had to ask themselves, you know, what kind of questions? How do I know if this is real or fake? How do I know if the motion, that Kobe's motion here, follows that projectile motion? And it really is a great way to use the video analysis skills, and it's very engaging. Another way that you might use the video analysis app, we have, for instance, some collision videos just amongst these sample videos. You can record more than one, the motion of more than one object here. You know, you can add multiple, record, in this case, 2 carts, or you could have multiple things, and look at the motion of 2 colliding carts and look at the conservation of momentum there. Or the video analysis app will, even if you have more than one object shown, it will automatically calculate the center of mass for you, that sort of thing. Another thing that you might do is another one of the sample videos that's included with the app is these falling coffee filters. These coffee filters, this was recorded with high-speed video so that you can see these filters falling. This is only a single filter, and then these are stacks of 2, 3, 4, 5, 6 filters, and you can track the motion, and you can see those filters reach terminal velocity, and then from that you can figure out like a coefficient of aerodynamic drag. It's really a wonderful tool, and this video analysis app is something you can use for more than just projectile motion. You can use it for all of your motion mechanics studies.
Well, Josh, we are approaching the end of our session here. I don't know if you want to try to say anything about the projectile launcher or Graphical Analysis Pro really quickly.
I guess before I move from video analysis, we do offer a free 30-day trial with the video analysis app. During that trial period, you can use it with your students. So if you're discussing projectile motion and you like this, you can use that activity that we've shared in with this workshop. If you just go to our website, Vernier, and search for Vernier Video Analysis, there's a free trial. You fill out a form and submit it to us, and then usually within 24 hours, you'll get an email from us to start your trial. You click on the link and you are pretty much good to go. That'll open it. And like I said, you can use it with your students. So you can, even if you don't have the budget this year to purchase the app, you can do a projectile motion unit using it. Along those lines, some other things that we have, we do have a projectile launcher. Our projectile launcher is, Dave used the photo gate to measure the motion of the speed of the marble through the photo gate. this is much the same sort of way. There is the sensor in this is also a photo gate, or rather a pair of photo gates. But it has the added bonus of, you connect like a pump to it. You put your marble, your projectile in there, you pump it up, and then you launch it, and it shoots it out at a very consistent speed, and from the photo gates, you get a launch velocity. If you're in a lab setting where you actually have, or you're in person, you have students, this is great because you get really consistent readings. You can set it to a certain range, and it always fires at to that same range. It's the consistency is the key, and it makes it great. You can do the same sort of activity like Dave did today, where you fire it 10 times to get an average velocity, and then use that to predict where it's going to land. In Dave's activity, it's just rolling off a tabletop, so you really, that initial velocity is just horizontal. With this, you can fire it at anywhere between 0 and 90 degrees. So you can really have you can really do full projectile motion doing that way. Dave also mentioned the Vernier Graphical Analysis Pro. That's kind of a paid version of our free graphical analysis software. So if you download graphical analysis from our website, you can connect our sensors to it and collect data into it. You can also just manually enter data and analyze that data. If you pay for the subscription for the Pro service, right now that adds a number of sample movies, or sample data with synced movies in them, and it allows you to create data files that have videos synced to the data collection. Let me share that with you real quick. I'm going to share my screen.
We just have a couple of minutes there, Josh.
Are there any questions we should answer?
Well, there's still a question about the uncertainty about a numerical value.
Oh, like a numerical value?
Yeah.
So when you do like a curve fit and that sort of thing, you get like things like, the best fit parameters. They don't have an uncertainty assigned to them, but that's primarily a limitation of the Vernier Graphical Analysis app itself. If you were to export the data, you could import it into our Logger Pro software, and there you would get Logger Pro's been around a lot longer, has more features. It will actually give you uncertainty measurements on those fitting parameters. That feature will probably be added to graphical analysis and video, or Vernier video analysis in the future. It just isn't there right now.
Yeah, there was an error bar question there, and what he mentioned about being able to open it up in Logger Pro. Logger Pro allows you to put error bars in there where you look at, say, a percentage of an uncertainty or something like that, but it's not available inside of graphical analysis yet. It's a fairly common question there.
So the Graphical Analysis Pro, that looks just like regular graphical analysis. You'll see that once if you've got the Pro service, it includes these sample experiments, and we can actually go and find. I'm going to filter this down here to physics with Vernier, and Dave did this lab right here, projectile motion with the photo gate. I'm going to download that here, and now you'll see it's a data set very similar to what Dave was showing earlier, where you've got these launch velocities off the edge of the table that you can do an analysis on. But it also has video recorded here. And in this case, it's not synced to anything because this, it's just showing the setup and that sort of thing. But for a remote learning situation, this can be really handy to be able to, for students to be able to see the experimental setup that was used to generate this data. If you look at another one, let me show you one where the data is synced. I'll do the same sort of thing and go to the physics with Vernier. And here's card on a ramp. This is a real simple activity where students roll a cart up a ramp and back down. Again, looking for that projectile motion. And you can replay this in such a way that the video and the data are synced together. So as you move along, you look at the data here, the video advances with it, and they can get a sense for how does this data connect to the physical phenomenon. As Dave mentioned, our Graphical Analysis Pro service just launched yesterday, so it's pretty new. And it also is you can find it through our website, you know, yeah.
Okay. So I know there were still some questions there involving the uncertainty. I'm going to try to post some things in the Q&A about that. I was trying to pull it up when we were talking. It's a bit hard to do that. So, but I want to go ahead and let me go back and do my video here. So we want to honor your time, and so we'd like to wrap this up. We might keep it going for a few minutes there, so if we still need to work on some of those questions. This is recorded so that, or was recorded, so it'll be put up on the website, so if you want to go back and look at it. We do have other ones coming up. I know next week, I think we're going to be doing a Newton's Law for physics, so we'll be using some sensors for that. That would be different than what we saw today. And so there are definitely other ones coming up there. So, so let's see, other questions. Well, so I guess at this point, I want to end this. The error bar question, I was trying to look it up and I was having trouble when I was going. I don't know. Josh, can you pull maybe an answer up for that and post it in the questions?
About how to...
Well, but basically how to do, you know, the question about error bars.
How to show them in Logger Pro, or?
Yeah, well, since that's going to be the answer, that's really the only answer. And I was trying to pull it up and I was having an issue there that was not letting me go for a second. So I just want to be able to put that up there in the answer. Oh, there was a question about the number of students that can use it. The license is a site license for the school. So that 149 covers the entire school. You invite all the students to use it, and then they can they can use it with their phones and all of that. I was having a discussion with somebody at a college recently who's there, in a kind of a hybrid situation, partially virtual, partially not. And he said, the video analysis is like the core of what they are now doing, because the students have the app and they can actually go out and do kinematics with the app and be outside of the class to be able to do that. So, okay, well, everybody, we'll end this and hopefully we'll see you in another one. Take care. Bye-bye.
Bye-bye.